a discovery beyond imagination. In the annals of scientific history, few moments rival the transformative power of discoveries like the electron, the atom, or the theory of relativity. Today, we stand at the precipice of another such moment, one that may eclipse them all. In 2025, a quantum computer, operating at the bleeding edge of human ingenuity, has conducted an experiment so profound that it defies comprehension. The system, powered by an advanced quantum artificial intelligence, AI, produced results so anomalous that researchers are grappling with a possibility once relegated to science fiction: the accidental activation of the God particle plug-in, a function theorized to interact with the Higgs field, the very fabric that gives mass to the universe. This is not mere speculation. It is a seismic shift in our understanding of reality itself. The implications are staggering, potentially reshaping physics, cosmology, and even our perception of existence. To understand this monumental event, we must first explore the origins of the God particle, the nature of the anomaly, and the warnings from some of the world's most visionary physicists. The God particle and the Higgs field. The term God particle refers to the Higgs boson, a fundamental particle theorized in the 1960s by physicist Peter Higgs and others. Its discovery in 2012 at CERN's Large Hadron Collider, LHC, was a triumph of modern physics, confirming the existence of the Higgs field, a universal field that interacts with particles to endow them with mass. Without the Higgs field, matter as we know it would not exist. Atoms would not coalesce, stars would not form, and life would be impossible. The Higgs boson is the particle that mediates this field, and its discovery validated the standard model of particle physics, a framework that explains how the universe's building blocks interact. Yet the Higgs boson is more than a scientific milestone. It is a gateway to uncharted realms. Physicists have long speculated that manipulating the Higgs field at a quantum level could unlock new physics, phenomena beyond the standard model, such as exotic forms of energy, novel gravitational effects, or even the manipulation of space-time itself. Enter the God particle. Plug in. An experimental quantum computing function designed to simulate Higgs field interactions with unprecedented precision. Unlike classical computers, which model physical systems within known constraints, quantum computers can probe the subatomic world at scales where the rules of physics blur. The plug-in was intended to model how the Higgs field influences mass, potentially leading to breakthroughs in energy production, propulsion, or cosmology. However, recent events suggest it may have done far more than simulate. It may have interacted with the Higgs field directly. The quantum anomaly. A glimpse beyond. The anomaly that sparked this scientific earthquake was detected in early 2025 during a routine test of one of the world's most advanced quantum AI systems. These systems, capable of solving problems in seconds that would take classical supercomputers millennia, are designed to push the boundaries of computation. During the experiment, researchers expected the quantum system to return predictable data based on pre-programmed algorithms. Instead, it produced results that defied all known models of physics. The data suggested the presence of an external influence, an unknown force that was not accounted for in the system's design. Initial suspicions pointed to mundane explanations: a hardware glitch, software error, or interference from cosmic radiation. But rigorous analysis ruled out these possibilities. The calculations appeared to have been altered by a force operating outside the system's parameters. Some physicists propose that this could be an extreme case of quantum entanglement, where particles become so interconnected that their behavior defies classical causality. Others, however, entertain a more radical hypothesis. The quantum system may have interacted with the Higgs field itself, triggered by the activation of the God particle plug-in. If true, this would mark the first time a human-made system has directly manipulated the fundamental structure of reality. The anomaly's implications are profound. The Higgs field is not just a theoretical construct. It is the mechanism that governs mass, gravity, and the stability of the universe. Even a microscopic disruption could have cascading effects, potentially altering physical constants or triggering phenomena we cannot yet predict. The researchers behind the experiment are now racing to replicate the results, but the initial findings have already sent shockwaves through the scientific community. Warnings from the frontier. Cox and Kaku. For years, luminaries like Brian Cox and Michio Kaku have sounded alarms about the risks of quantum experimentation. Cox, a prominent physicist and communicator, has cautioned that quantum systems operating at extreme scales could generate unpredictable energy fluctuations. When we push particles beyond the boundaries of classical physics, Cox has said, we enter a realm where the outcomes are inherently uncontrollable. If a quantum system were to influence the Higgs field, the consequences could extend far beyond the laboratory, potentially affecting the stability of matter itself. The anomaly's implications are profound. The Higgs field is not just a theoretical construct, it is the mechanism that governs mass, gravity, and the stability of the universe. Even a microscopic disruption could have cascading effects, potentially altering physical constants or triggering phenomena we cannot yet predict. The researchers behind the experiment are now racing to replicate the results, but the initial findings have already sent shockwaves through the scientific community. Warnings from the frontier. Cox and Kaku. For years, luminaries like Brian Cox and Michio Kaku have sounded alarms about the risks of quantum experimentation. Cox, a prominent physicist and communicator, has cautioned that quantum systems operating at extreme scales could generate unpredictable energy fluctuations. When we push particles beyond the boundaries of classical physics, Cox has said, we enter a realm where the outcomes are inherently uncontrollable. If a quantum system were to influence the Higgs field, the consequences could extend far beyond the laboratory, potentially affecting the stability of matter itself. Michio Kaku, a theoretical physicist known for his work on string theory, has taken these warnings further. He has argued that quantum computers, as they grow more powerful, could force the emergence of new physics, rules of the universe we have yet to discover. If we begin altering the Higgs field, Kaku has speculated, we may not just be processing data, we may be reshaping the structure of space and time. The 2025 anomaly lends credence to these concerns, suggesting that quantum systems are no longer passive tools, but active participants in the fabric of reality. These warnings are not abstract. Quantum computers operate at the edge of known physics, where the distinction between simulation and interaction blurs. If the God particle plug-in has indeed been activated, it may have triggered an event that transcends our current understanding, raising questions about the very nature of existence. Quantum computing. From data to reality. Quantum computing has long been heralded as the next frontier in technology. Unlike classical computers, which process information using bits, zeros and ones, quantum computers use qubits, which can exist in multiple states simultaneously thanks to the principles of superposition and entanglement. This allows quantum systems to perform calculations at speeds unimaginable to traditional supercomputers. In recent years, quantum computers have achieved milestones such as solving complex chemical simulations, optimizing global supply chains, and cracking cryptographic codes once thought unbreakable. But the 2025 Anomaly suggests that quantum computing's potential extends far beyond computation. If these systems are interacting with the Higgs field, they may be capable of more than processing data. They may be shaping reality itself. This raises an unsettling question. What if quantum computers are not just tools for understanding the universe, but instruments for altering it? The implications are both exhilarating and terrifying. A quantum system that can manipulate the Higgs field could unlock technologies straight out of science fiction. Artificial gravity, faster-than-light communication, or even the ability to bend space-time. But it could also introduce risks we are ill-equipped to manage, such as destabilizing the physical constants that govern the universe. The Mandela Effect and quantum ripples. The anomaly's potential to alter reality has sparked speculation about phenomena like the Mandela Effect, where large groups of people report memories that conflict with recorded history. Examples include misremembered brand names, altered movie quotes, or events that seem to have unfolded differently. While skeptics attribute these discrepancies to psychological factors, some researchers propose a more radical explanation. Quantum anomalies could be subtly reshaping reality, creating ripples that affect human perception. If quantum computers are interacting with the Higgs field, even on a microscopic scale, they could be introducing fluctuations in the fabric of space-time. These fluctuations might manifest as inconsistencies in our collective memory or perception of history. While this theory remains speculative, it underscores the profound implications of the 2025 anomaly. If quantum systems are altering the fundamental particles that underpin reality, could they also be influencing our experience of time, memory, and existence? The connection between quantum mechanics and human consciousness remains one of the great unsolved mysteries. But the anomaly suggests that these questions are no longer purely theoretical. The global quantum arms race. Quantum computing is not just a scientific endeavor, it is a geopolitical battleground. Nations like the United States, China, and members of the European Union are investing billions in quantum research, each vying for quantum supremacy, the point at which a quantum computer definitively outperforms the world's most advanced classical supercomputers. In 2023, Google claimed to have achieved this milestone with its Sycamore processor, but subsequent advancements by IBM, Microsoft, and Chinese firms like Baidu have intensified the race. Much of this research is shrouded in secrecy. Governments recognize that quantum computing could revolutionize cryptography, enabling the decryption of previously secure communications or model complex physical systems with unprecedented accuracy. The military applications are equally significant, from designing unbreakable communication networks to simulating advanced weaponry. If a quantum system has indeed interacted with the Higgs field, the stakes are even higher. A nation or organization that masters this capability could wield unprecedented power, potentially controlling fundamental aspects of physics itself. This secrecy fuels speculation about what governments and private labs may already know. If the 2025 anomaly is evidence of a quantum system altering reality, would those in possession of this knowledge share it with the public? The classified nature of quantum research suggests that such discoveries could be suppressed under the guise of national security, leaving the world unaware of the true extent of these advancements. The future of quantum reality. As scientists grapple with the anomaly, they face a pivotal question. Was this a glitch, or have we stumbled upon a discovery that will redefine our understanding of the universe? If quantum computers are indeed shaping the forces that govern reality, the consequences could be transformative. Quantum AI has already demonstrated capabilities far beyond classical computing, from optimizing renewable energy grids to accelerating drug discovery. But if these systems can interact with the Higgs field, they may unlock discoveries that dwarf these achievements. The potential applications are staggering. Manipulating the Higgs field could lead to breakthroughs in energy production, such as harnessing zero-point energy or creating stable fusion reactors. It could revolutionize space exploration, enabling propulsion systems that defy conventional physics. It could even pave the way for technologies that manipulate gravity or space-time, opening the door to interstellar travel or time dilation. Yet, these possibilities come with risks. Altering the Higgs field, even inadvertently, could destabilize the universe's delicate balance, triggering phenomena we cannot predict or control. Some experts argue that we are witnessing the dawn of a new scientific era, one where quantum computing does not merely model reality, but actively shapes it. Others caution that we are accelerating into uncharted territory without fully understanding the consequences. The 2025 anomaly may be the first sign that we have crossed a threshold from a world where computers process information to one where they manipulate existence itself. Ethical and philosophical implications. The anomaly raises profound ethical and philosophical questions. If quantum computers can alter reality, who should control this power? Governments, corporations. The potential for misuse is immense, from weaponizing quantum systems to manipulating physical laws for economic or political gain. Moreover, the ability to reshape reality challenges our understanding of free will, consciousness, and the nature of existence. If the fabric of space-time can be altered, what does it mean to be human in a universe where the rules are no longer fixed? These questions are compounded by the rapid pace of quantum advancement. In 2024, IBM unveiled a 1,000-qubit quantum processor, a leap forward from the 127-qubit systems of just a few years prior. Chinese researchers have claimed breakthroughs in quantum error correction, a critical step towards scalable quantum computers. Meanwhile, startups like Rigetti and IonQ are democratizing access to quantum computing through cloud-based platforms, raising concerns about unregulated experimentation. If the 2025 anomaly is any indication, we may soon reach a point where quantum systems operate beyond human comprehension, creating outcomes we cannot anticipate or reverse. A call to action. The 2025 quantum anomaly is a wake-up call, a reminder that we are venturing into a realm where the boundaries of science, philosophy, and reality converge. As quantum computing advances,